Good day, I'm Reyes, and I'm going to report about esterification in lipids and the major metabolic pathways. So, first of all, what is esterification? Esterification, also known as picture esterification, is the esterification of a carboxylic acid by heating it with an alcohol in the presence of a strong acid as the catalyst. So, as you can see here below, we have the mechanism for esterification. We, we have here a carboxylic acid and an alcohol, which results in the formation of ester by the presence of strong acid as the catalyst. Here we have the sulfuric acid as an example of a strong acid. So in lipids and its major metabolic pathways, we can see the esterification process through the synthesis of triglycerides. So what exactly is a triglyceride? Triglycerides are a type of fat or lipid found in your blood. When you eat, your body converts any calories it doesn't need to use right away into triglycerides. The triglycerides are stored in your fat cells. Later, hormones release triglycerides for energy between meals. It is also called triacylglyceride or triacylglycerol, a major storage form of lipid in the body, composed of a glycerol backbone and three esterified fatty acids. As you can see here, we have the glycerol and three fatty acids, which results in the formation of triglycerides. So the major building block for the synthesis of triglycerides in tissues other than adipose tissue is glycerol. So adipocytes lack glycerol kinase, therefore dihydroxyacetone phosphate or DHAP, which is produced from glucose during your glycolysis here, the glucose during glycolysis, is the precursor for triglyceride synthesis in adipose tissue. The vast majority of the glycerol 3-phosphate is derived from the glycolytic intermediate dihydroxyacetone phosphate here by the action of cytosolic NAD-linked glycerol 3-phosphate dehydrogenase here. In the liver and kidney, a small amount of glycerol 3-phosphate is also formed from glycerol by the action of glycerol kinase here. So these two processes both result in the formation of L-glycerol 3-phosphate. The other precursors of triacylglycerols are fatty acyl-CoAs, formed from fatty acids by acyl-CoA synthetases, the same enzymes responsible for the activation of fatty acids for beta oxidation. The first step in the biosynthesis of triacylglycerides is the acylation of the two free hydroxyl groups of L-glycerol 3-phosphate by two molecules of fatty acyl-CoA to yield the acylglycerol 3-phosphate, which is more commonly known as phosphatidic acid or phosphatidate. So here we have the L-glycerol 3-phosphate, and we have here the two fatty acyl-CoAs. Here we have one fatty acyl-CoA and one fatty acyl-CoA here. All can be converted. So these two will link with the L-glycerol 3-phosphate with the help of acyltransferase to create phosphatidic acid here, or diacylglycerides, because we have two free fatty acids, acyl-CoAs. And so phosphatidic acid is found in small amount in cells but is a central intermediate in lipid biosynthesis. It can be converted either to a triacylglyceride or to a glycerophospholipid. So here in the second step of triacylglyceride biosynthesis, phosphatidic acid thus formed is hydrolyzed by phosphatidic acid phosphatase. Here it hydrolyzes a phosphatidic acid to form a 1,2-deacylglycerol. Here, 1,2-deacylglycerol. So here on the other hand, we have the phosphatidic acid, which is converted into glycerophospholipid. So the next step is, okay, so the acylglycerols obtained from step 2 here, the acylglycerol here, are then converted to triacylglycerols with the incorporation of a third fatty acyl-CoA by an enzyme acyl transferase here. Another one, so it's just the same process, but this time we add the third fatty acyl-CoA, which is why it's now called a triacyl glycerol. So this process is called trans-esterification. So if we all remember here, let's go back, we have the L-glycerol 3-phosphate. So it is not shown here, but here we have the phosphate group. So yeah, we have the phosphate group there. Okay, so here the phosphate group here. To remove that, we have to use the enzyme called phosphatase. So the phosphatase basically breaks the bond between the oxygen from the glycerol and the phosphorus from the phosphate group. So we could easily attach the fatty acyl-CoA. So in short, the linkage of the three fatty acyl-CoAs with glycerol is the process of creating a triglyceride. So these are my references, and thank you for listening. The next part will be reported by my groupmate.